Alrighty guys, so this is our last lesson actually of the year, okay? We are working on what's called geometric series, sequences and series, okay, worksheet 9-3. So I'm going to introduce, so our other famous sequence is arithmetic, okay? So this is our other one called geometric, okay? And this has a very specific pattern. So if you take a look here, right? We have here a diagram, right? And this is stage one of the diagrams of a snowflake curve, okay? Stage one, right? This is our stage number or our n. All right, so this is an example of a geometric sequence, okay? So stage one, there's 3 sides, okay? So this is kind of like your A sub n, all right? So when n is 1, stage 1, we have 3 sides. When n is 2, okay, then we have 12 sides. So if you kind of see, now our shape has not just one triangle, right? Right, but we have multiple sides here. Then, I don't even know how to create this myself, but stage 3, right? So that's our n again, has 48 sides. Okay, so you can see the number of sides are growing, but growing pretty rapidly, okay? So if you look, right, this should be stage 4. So it's saying, it doesn't give you a picture, and it would be very hard to draw the picture, but how many sides would stage 4 have? So if you take a look here, the pattern, right, clearly cannot be arithmetic, because here if you do 12 minus 3, you get 9. And then 48 minus 12, that clearly isn't the same number being added here. So this one has to be a different type of pattern, okay? So what you have to look at here is this is a geometric sequence, okay? So if I take a look here, the way you test for a geometric sequence is you don't use subtraction between the two, you use division. So 12 divided by 3 is 4. Okay, then if we do this and we do 48, always taking a term and dividing by the previous instead of subtracting, we get 48 divided by 12 is, oh, look at that, 4. So that means really what we're doing here is our pattern is we're multiplying by 4 to get the next term. Okay, so if I want the 4th stage right here, or when n is 4, I'm going to take 48, right, and multiply by 4. So 4 times 48, what does that give me? 1, so 4, 160, 32, so 192. And that's how many sides we would have, which is crazy, okay? That's a lot of sides. We would never be able to really draw that, okay? So in a geometric sequence, okay, the ratio of any term to the previous term is constant, okay? So this is called the common ratio, all right, which is denoted by R. So now here, if you take a look, R is going to be 4, okay? So instead of finding D like we did before, we're gonna have to find R, okay? So it's just a different variable, all right? So this is changing by multiplication, all right? I'm just grabbing my calculator because you're definitely gonna need your calculator for this one, okay? Because the numbers are gonna get kind of big because we have what's called a constant multiplier here, okay? So that's what I like to call it also, or the common ratio, okay, which is R, but that's gonna be the number. So if I multiply by something over and over, the numbers are gonna get pretty big. So you're definitely gonna wanna have your calculator, okay? So the first thing you're gonna do here is determine if it's geometric, okay? So if you take a look, right, it needs to have a common ratio. So you're gonna use ratios to find the common ratio. So you're always gonna take, to find R, right? All right, you're gonna do a term and divide it by the previous term. So if you remember, before we did a term subtract the previous term, now we're going to do a sub n divided by a sub n minus 1. This just means one term less than, so the previous term. Okay, you don't have to know this, okay, as far as this notation, but you do know how to find it, okay. So if I take a look at this guy, I can see it's decreasing, okay. So if I search, since they're asking me for geometric, I'm going to do my formula here to find r, and I'm going to do 16 divided by 32, which is 1/2, right? Then if I do 8 divided by 16, I get 1/2. Then 4 divided by 8 is 1/2, and then 2 divided by 4 is also 1/2. You have to make sure they're all constant, okay? So that means my r is 1/2, okay? Couple things to be aware of that I'm going to mention during this lesson is do not think of this as division by 2, because when we go to write our formula in the next step, you're going to have to use multiplication, okay? So you want to figure out what the constant multiplier is, not the constant divider, all right? So r is 1/2. So is this geometric? Yes, because, and you could say the r value is 1/2. You could say there's a constant multiplier of 1/2, however you want to say it, okay? But you have to mention that r/2 being the 1/2 as constant, all right? Then if I look at this guy, I can see the numbers are increasing pretty rapidly, so this might be geometric, okay? So I'm going to test it. So r, right, should be 2/1. So I should get a r of 2 all the time. So then if I do 6 divided by 2, I get 3. So the minute that these are not the same, then it's not geometric. Okay, so there is no constant multiplier, okay? So in this example, let me just move that over a little bit. In this example, we're multiplying by 2 to get from 1 to 2, and here to get from 2 to 6, you might just see this. You might not need to do the division. You're multiplying by 3, so this is not constant, so this is not geometric, okay? So the first couple on the homework will be like that, okay? Now let's take a look at actually writing the rule. Now the good news is the rule for geometric is actually easier. Okay, so we're gonna move on to that. Ooh, there is one thing I wanna do here. No, I think we're good. Yeah, okay. So you're gonna tell if the sequence is geometric, all right? You're gonna do that for the homework. Then here is our rule, okay? So to find any term number, right, we're gonna take a sub 1. So remember, that's the first term. And we're gonna multiply that, and I'm gonna put some parentheses there just to show that times r to this power, okay? So r is our common ratio. Woo. Add an n on there, or multiplier. Okay. And then n, right, is the term number. Okay, so we're going to use the same notation kind of as we did before, but you can see here now, if I use exponents, that means I'm multiplying by something over and over, which is what we're talking about when we do a geometric sequence. So here, if you look, right, hopefully in this example up above, you can see we're multiplying by 3 here. So r is 3. So that becomes the base of your exponential formula, right? The rule for the geometric sequence, okay? So a geometric sequence is really just an exponential equation, okay? So if you take a look, we're gonna write the rule for the nth term, okay? Sometimes called the explicit formula. You might see that, just so you're aware. Some books use that. Ours uses the nth term, but I don't want you to be thrown off by that, okay? So the explicit rule is just the nth term. Okay, so if I'm looking for the rule, right, I'm going to be using a sub n equals a sub 1 times r to the n minus 1, okay? So a sub n, remember, if we're trying to write the rule, just like we did with arithmetic, we don't know a sub n. okay? A sub 1 is our first term. So if I look here, my first term is 32. Then if I want to find my R value, I'm gonna work backwards, okay? So I'm gonna do 16 divided by 32, which reduces to 1/2. You can also use a decimal, okay? I'm gonna keep it in fraction form, but you can use a decimal. This is 1/2, okay? I only have to do this once because they already told me it was geometric, so if I find the common ratio is 1/2, that will hold true for the rest of the sequence, okay? So R is 1/2, and then N, we don't know because we're looking for the rule for the nth term, right? Those two we don't know. So now if I plug it in, A sub N is gonna be 32 times 1/2 to the N minus 1 power. Now here's the deal. The N minus 1 only applies to the 1/2. It does not apply to this coefficient of 32. So you cannot multiply these two, all right? So if you think about PEMDAS, right? If I plug in N, a value for N, what's gonna happen is I'm going to simplify that, raise 1/2 to that power, and then multiply by 32, okay? So do not try, okay, to simplify this, okay? That is the rule. So unlike with arithmetic, once you plug it in, you're done, okay? That's our rule. Now we want to find A sub 8. So that means that's telling me N is 8. So if I plug that in, right, I know N is 8 now, I'm going to say A sub 8, and make sure that's a subscript, equals 32 times 1/2 to the 8 minus 1. So A sub 8 equals 32 times 1/2 to the 7th, okay? And then I'm going to let the calculator do all the work. Okay, I know this number is going to be pretty small because I'm going to the 8th term, right? And I'm multiplying by 1/2 7 times. That's what this is telling me, right? So 32 multiplied by 1/2 7 times. So I'm going to take 1/2 and then 1/2 and then 1/2. So here, raise that to the 7th. So now, oh, what did I do wrong here? Go to, oh, I forgot the 7. Let's put the 7 in. Okay, so then I get 0.25, okay? So A sub 8 is 0.25, or you might recognize that that's 1/4, okay? Either one, all right? So that's our A sub 8. I can take it as a decimal, it can be a fraction, it's up to you, all right? Both are correct. So if you take a look at this guy, right? Write the rule for the nth term, okay? So they tell me A sub 4 is 54. So they've told me the 4th term. So if I think about this, the sequence, they've told me this is 54. They've also told me R is 3. So I don't need A sub N, right, to write the rule. I have R, I need A sub 1, don't I? So that's what I gotta find. And then I don't need N to find the rule. Okay, so I gotta work backwards to get to A sub 1. So this is A sub 4, A sub 3, A sub 2, A sub 1. So if you remember with arithmetic, that changed by, right, addition or subtraction, and we always did the opposite. All right, so if my rule is R equals 3 and I multiply by 3 each time, what I'm gonna do here is do the opposite of multiplication, which is division. So I'm going to divide by 3 to get back to my A sub 1. So if I do 54 divided by 3, I get 18. Then I divide by 3 again, I get 6. And I divide by 3 again, and I get 2. So that means A sub 1 is 2. So you're just working backwards, that's it, all right? So then my rule is going to be A sub N equals A sub 1 times R to the N minus 1. I'm just going to plug it in, so A sub 1 is 2, R is 2, and then N minus 1. Do not multiply these two, right? This 2 is raised to this power and then multiplied by that coefficient, so leave that, okay? We're not going to graph. I don't ask you to graph, so if the homework does ask you to graph, You will see in my answer key, I did not do that. Don't worry about graphing, okay? So that's writing our rule, okay? So to find the first term, you might have to work backwards, all right? And it's always division when you're working backwards. I'm gonna write that. Always division when working backwards. Okay, because it's always multiplication. You're always trying to find the common ratio or the multiplier. So if I'm trying to find what I multiply by all the time, if I have to work backwards, I'm always going to use division, okay? So let's take a look now, okay? So we want to find the nth rule, okay? So if you take a look at these guys, okay, notice I said don't graph the sequence, okay? So don't worry about that, all right? So if I take a look at the first one, right, I can see this is telling me it's geometric, okay? So for number 4, they give me the sequence. So I'm looking here, I need a sub n, but I'm gonna write the formula, right, the rule. So a sub n is, I don't know, and I don't need to know. A sub 1 is 5. R, well, if I look here, R should be 20 divided by 5, which is 4, right? Now, since it's geometric, if I find the ratio of 2 terms, right, second divided by the first, that will give me my R, okay? And then n, I don't know, right, because I'm writing the rule. So then a sub n equals a1 times r to the n minus 1. I just plug in. This is 5 times 4 to the n minus 1. That's it. That's your rule. You don't have to do anything else. So that's for number 4. Now, if I look at number 6, let's say, okay, this is a little different, okay? Remember, we're trying to find a sub n, or write the rule for a sub n. We need a sub 1. If I look at number 6, I don't have a sub 1, so I have to find that. So what they've told me is that this is the third term. So if I have a sub 3, I gotta work backwards to get to a sub 1. This is at 96. Remember, we're gonna take r, so we have r, and we're gonna divide by that quantity, okay? So 96 divided by 4, right, is 24. And then that divided by 4 is 6. So a sub 1 is 6, okay? So now, and I don't know my n because I'm trying to find that, right? Use the formula. So a sub n is a1 times r to the n minus 1. So that's 6 times r is 4, n minus 1, and you are done. Okay, we're just writing the rule, okay? So there's my 2 rules. So the first one was easier because we had a sub 1. This one, you just had to find the a sub 1. Last but not least, we're finding our geometric series, okay? So remember, series just means we're adding, all right? This is the formula, okay? You should have the formulas handy when you're doing your homework, but you can see it's the same notation, S sub n, so the sum through n terms is a sub 1, right, which is our first term. And then in parentheses, right, you're gonna do 1 minus r to the n. Notice this is n, not n minus 1. So sometimes we get mixed up with that. Just be careful, okay? Divided by 1 minus r, okay? So we're gonna plug into this guy. R is, right, our common ratio. Okay, and n is the number of terms. So if I look here, I'm taking a geometric series, okay? That's what the homework's gonna say, the first 10 terms. Now, just like I said before, geometric is actually easier than arithmetic because in arithmetic it was kind of annoying we needed to know what the last term was at the end. We don't need that for geometric, okay? So for geometric, we need a sub 1 and we need to know what r is. Well, a sub 1 is already listed for us. Then if I want to find r, I'm going to take the second term divided by the first term. So here it's 2. Now you might be able to see right away that it's 2. That's fine as well. So, because 5 times 2 is 10, 10 times 2 is 20, so r is 2. So then when I go to do my formula, I'm going to do, this is 10, because we're summing through 10 terms, so n is 10, r is 2, a sub 1 is 5. So we're going to do the sum through 10 terms, right? So I'm just using our formula, equals a sub 1, which is 5, times 1 minus 2 to the n, so that's 10, over 1 minus 2. Now, I highly suggest you do this in steps, okay? It's just using a formula, but your calculator, unless you're very careful with the way you enter it, your calculator can't handle all this at the same time. So we're going to do the numerator and the denominator. So simplify the numerator and denominator first, okay, on your calculator. So I'm just going to go ahead and literally put in my calculator what they give me. So 1 minus 2 to the 10th is negative 1,023 over 1 minus 2 is negative 1. And then divide these two. Now it's just negative 1, so that becomes positive. So then it's 5 times 1,023. This number might not always be nice, and that's okay, all right? But we're going to take that. So 1,023 times 5, and these numbers are going to get big, right? 5,115 is my sum. That's not too bad. But sometimes, depending on how many terms you have and how big it's getting, how quickly it's getting big, so like if your R was 5 or something, that's how it's growing by a factor of 5, so it's going to get pretty big pretty quickly. So your numbers might be big. Don't think you're wrong if you get larger numbers, all right? All right, so let's take a look at another one. So here we have some sums. Okay, so this guy, it's a geometric first 10 terms. So my formula is S sub n equals A1, 1 minus r to the n, 1 minus r. So n is 10, okay, and again, that can change, all right, depending on how many terms they want us to sum through. A sub 1 is 3, okay, and then r, you can hopefully see that we're multiplying by 3 each time here, okay? So r is 3, so then I'm going to plug it in. So S sub 10 equals 3 times 1 minus 3 to the 10th over 1 minus 3. Then I simplify numerator and denominator. I have no idea what that is. So 1 minus 3 to the 10th. So that's 59,000, negative 59,048 over negative 2. Okay, because 1 minus 3. So now, if I take this number divided by negative 2, I get 29,524. Then I multiply that guy by 3, and I get 88,572. So a little bigger. Okay, again, it can be millions. All right, so don't think you're wrong. But that's our sum through 10. So I can see sum through 10 terms, right? And that's our answer. Now this guy's a little trickier. Okay, if you see the sum, right? I mean, the series is decreasing, right? So if I look here, my R, right, if I do 10 divided by 20, that's 1/2, okay, or 0.5. So you just have to be careful here when you end up with fractions. You could use a decimal as well. But here we're going to do, the n is still 10, okay? A sub 1 is 20, so we're going to do the sum through 10 terms, right, equals, so I'm just using our formula, A sub 1, which is 20, 1 minus 1/2 to the 10th power, so that's my R, and then 1 minus 1/2. Okay, so S sub 10 equals 20. So now I'm going to do 1 minus 1/2, you could also again use 0.5, to the 10th power, and I get that. Do not round. And then 1 minus 1/2 is 1/2. So we're gonna take that decimal, right, and divide it by parentheses 1/2. Okay, so notice I put that in parentheses. Again, you could be using 0.5, that's fine. I get that, 1.998, okay? So 20 times 1.99804, don't round, okay? Leave it there, and then I take that guy and multiply by 20.
600.
Okay, so then my sum is 39.96. Wow. Okay, so that's the decimal about what it would be, okay?